Hey everyone, we're going to finish off 7.3 with the p-value method. So here are the steps involved, which are same 6 steps, but now we're doing p-value instead of critical value. So a lot of the steps are the same. I've already got this one started with the same things that we did in example number 4. But the next thing we'll need at this point is the p-value. All right, so in order to get that p-value, the only way to do it is with technology. So we're going to have to do some StatCrunch. And so I'm going to load a StatCrunch page, and let's give it a go. So in your main page, just open up a blank spreadsheet, and then where it's located is under Stat. So click on Stat, and then we're doing T distributions. So you're going to go down to where it says T-Stat. It's the 5th one down, T-Stat. And this is just one sample. And we have the summary because we have X bar and S, etc. Okay, and then there it is. So notice what we've got to input is all of that, all of those summary statistics. So the sample mean for this problem is 12.4. The standard deviation for this problem is 1.2. And the sample size, 20. Now for the hypothesis test, in this box where it says mu equals, that comes from the hypotheses, that's the 13. And then I got to get the HA inequality right, and I have 3 choices. And just make sure it matches your HA. So in this problem, it's a less than. Don't worry that the HO isn't equals, it's just always equals, you can't change it. So just make sure to get the HA right, and you'll be fine. And then there's nothing else to do. You could show the critical value if you want to. That might help if you're doing the critical value method. You could use this way as well, right? So if I click compute, then I get all of my information. I got the sample means. Don't worry about standard error. Got the DF. There's that T-stat. Notice we did that by hand, negative 2.24. We get that for free here with StatCrunch as well. Also that critical value, when we did the critical value method, we could have used this as well for that. And then we get this new value, the p-value, 0.0188. And since we're doing the p-value method, we're going to do that. So really, you could do this method for p-value or critical value method. It works for both. Pretty nice. Okay, so I'm going to go back to my handout and record that 0.0188. And now remember how p-value methods work. You compare that to the alpha, 0.05. And notice here that that is less than 0.05, which is the alpha. Right? And anytime that p is less than alpha, that's when you reject H sub 0. Okay, and then now our conclusion is the same as we did before. We rejected H sub 0, HA is the claim, so this is sufficient to support. There is sufficient evidence to support the claim. I'm just giving you the keywords as I go through these. Okay, so if we tried another one with that method, so again, HO, HA, same, right? This is the one where we had mu equals 22,500 and not equal 22,500, and the claim was the HA. Okay, so same problem as number 5. And then when I go through back to StatCrunch, I'm going to close that down, and I'm going to start it again. So I'm going to go stat, T-stat, one sample with summary, enter in my data. So in this one, the sample mean was 21,545. The sample standard deviation was 3,015, and the sample size 25. Okay. And in the hypotheses, it was 22,500. And then the inequality for the HA was the not equals. I could show the critical value for fun, and then hit compute. Okay, so I can double check my critical value when I did this before. That's what we got, 2.064. And then I also get the p-value, right, and the t, right? So, which we did before with just the formula, but I'll just record those values on the handout. So my output, I get t equals negative 1.58, and I get p equals 0.1263. Is it 1263? Sorry. Yeah, 11263. I was right. Okay. Compare that P to the alpha. Notice here now P is larger than alpha, right, of the 5% there. So when that happens, it's fail to reject H sub 0, and the same conclusion, insufficient to support. Okay, great. So that's how it works. So just use that StatCrunch feature and you're good. Okay. Lastly, if you have raw data, you're definitely going to want to use StatCrunch for these. Right. So this one is a brand new one. Brochure says the mean class size is fewer than 32. Okay, so that would be an HA, right? Mu less than 32 is the claim from the brochure. HO would be the opposite of that. So this is a left-tailed test. We're getting pretty good at doing that. Okay. And then now to get the statistics, I'm just going to run my test. All right. Now what I got to do here is load the data. So I put these in your data folder, go to My Groups, the C1000, and it should be at the end at this point, the 7.3 problem 9 is what we're doing. So I got to load the data in there. Okay. If you're doing this in MyLab, there's that feature where you can load the data into StatCrunch. And then now I'm going to go through my same test. So I go stat, T, one sample, but now we have with data because we have the raw data. And then select your column, mean class size. Okay. Hypothesis test. And get the numbers right. So we had 32 in our hypotheses, and it was a left tail, which was less than. And we can show critical value. Okay. And then there's the setup. Hit compute, and we should be good. So these are nice. You only have to just select the column, select hypothesis test, put in the number and inequality, and you're good. Is our critical level of significance, got to get that right, is 01. I might have done that wrong previously. Make sure to get the level of significance if you care about that critical value. Right, make sure it's the right level of significance. So, and then we get compute. Okay, but really all we're after, because we're doing p-value, so here's the thing. You could do p-value or critical value. It just depends on which way you want to do it. Maybe we can do both on this one. So I'll just record all of this information, and we should be good. So on our output, we got a T, which is your standardized test statistic, the negative 1.94. We got a p-value. That was 0.0344, and we got that critical value, that's T sub 0, negative 2.57. So with that information, you should be able to make the correct conclusion. You could do p-value or critical value. So if I did p-value, I would compare it to alpha, 1%. So here that is bigger than 0.1, 0.01, right? Which is then fail to reject. I always cross my L's. Fail to reject. HO, right? So I know that. Or you could use the critical value if you want to draw that out. That works like left tail, right? Negative 2.57. And the T is here, negative 1.94, right outside of the region. So that would also be fail to reject. So either way, right? Either way, fail to reject is always the insufficient to, and then HA is the claim, so support. So there's insufficient to support the claim that the mean is less than 30, that the mean is greater than or equal to, wait a second, did I get that wrong? Okay, timeout. Test your claim that the class size is 32 or more. So I didn't read the fine print. Our claim, we're testing our claim, which is good. So everything is fine, but if we are the claim, then that changes this word to reject. And that's the only change. Okay, so actually that's a good thing to point out. The wording of the problem is going to tell you which one is the claim, HO or HA. If HO is the claim, you're going to use the word reject. If HA is the claim, you're going to use the word support. But either way, it's still insufficient because we had fail to reject. Okay, so we got that one right, and we are good. Okay, we're going to stop there. We'll do 7.4 in the next video, but give those a try and let me know how it goes. Otherwise, hope all is well. Talk to you.